We are on page page 532. And for the part A, it says predict the graph. Okay, so we can describe this in two ways now. That 1/4 tells us two things. First of all, it's a vertical compression, y by half, but it also now tells us the amplitude is a half. The second number, the 3 is going to be a horizontal compression. X is going to get multiplied by 1/3. But now we can also say the period is 2 pi over 3. So as far as describing things go, we can describe it.
Shouldn't the vertical compression amplitude 2d 1/4?
Yes, what did I say?
Yeah, you said 1/2.
1/2, yeah, it's 1/4. Thank you. So we can describe it with our transformations, but we can also describe what it is with our shortcut as well. So the pi over 6, that's going to be a horizontal translation, pi over 6 to the left, and we know that a sine graph, or this is cos graph, a cos graph starts at a maximum. So now our maximum is going to be shifted pi over 6 to the left. And finally, the last thing on here is the +2. That's a vertical translation, 2 up. And that means our sinusoidal axis is going to be at y equals 2. Now I'm going to get you to put a line through this. Because when I ask you this question on a quiz or a test, I will get you to sketch something for at least one period. So how do we go about sketching this? We're going to use the shortcut, the DAVC. What does that mean? We start with our sinusoidal axis, which is at y equals 2. Now, that's the D value, check. Next, A value. A value is amplitude. We use our amplitude to write our maximum and our minimum values. In this case, our amplitude is 0.25. So our maximum is only going to go up to 2.25, and our minimum 1.75. Hello. No problem. Okay. Oh, I can think too. Alright, sorry about that. So that is, you're going up to 5, labeling your maximum and minimum, that's your A value. Your B value finds your period. We figured it out already to be 2 pi over 3. Mark 2 pi over 3 somewhere on your x-axis and divide it into 4 equal sections. So the half of that would be pi over 3, half of that pi over 6. 3 of them would be 3 pi over 6. And that's the B value. Next, the dotted line. The dash, we draw the coast graph without the shift. So coast graph starts at a maximum, so you can start at the 2.25. Then at the next sticky mark, it's going to be center line, then minimum, then center line, then maximum. Draw that with the dotted line. So this is the coast graph with all of those characteristics except for the shift. So a little check mark on the dash. And the final thing is shifting it. We're shifting pi over 6 to the left. So I look at my scale, and this would be pi over 6 to the left. I take each of my points and shift them over that much. Put arrowheads on the end to say it keeps on going, and we've done at least one period of the graph. When it says list the characteristics, it's asking things like, my center line is at 2. My amplitude is 1/2. My period is 2 pi over 3. My domain is everything. My range goes from 1.75 to 2.25. So those would be things that we would call characteristics. All good? Almost? Yes? Well, because I know my amplitude is 1/4, which is 0.25. The A part of the DAB-C says, use your amplitude, and the definition of amplitude is from the center line to the maximum and center line to the minimum. So if my center line's at 2, and I'm going up 0.25 to my maximum, I'd get 2.25. And if I go down 0.25, I'd get 1.75. Okay, I'll get you to circle 3, 8, 9, 10, and 11. And I put a little star beside 11 because you have to factor first. It's not in factored form. Remember that note that we had from our transformations unit?